Hello everyone, welcome to the class once again. I hope you're all doing good and you're the best of your health. In today's class we'll be talking about exchange of heat or how heat is transmitted from one body to another body or from one place to another place. Now see, heat transfer takes place from basically three methods. It's conduction, convection and radiation. We will start with first understanding the concept of conduction and later on we will take away with convection and radiation. So let's start with transfer of heat process and let's go with the first process, that is conduction. So transfer of heat, that is how heat is transmitted from one body to another or from one place to another. Now see, transfer of heat, the first one, the basic method of transmission of heat, that is conduction. Now in conduction, this generally takes place in solids. It takes place in solid. Takes place in solids. Now there are many kinds of solids. We have wood as a solid, we have metals as solid. Takes place in solids. Now generally metals are good conductors of heat and they will be transmitting heat in the best way. That is, rate of transfer of heat through metals will be more better compared to transfer of heat rate in a wood or let's say any non-metal object. Now how conduction takes place in a solid object? See here. We all know that how a solid object is constructed, how it is made up of. Now see, in a solid object, there will be several molecules within the object. So what I'm going to do, I'm going to draw several molecules which comprise or which make up this solid object. So these molecules are tightly packed. All these circles that I am drawing, this represent any molecule that will be present within the solid object. Now we all know that a solid molecules are tightly packed. They will be present all over the object, they will be tightly packed. Now what happens? But there will be slight space where they can vibrate. Nearby their position they can vibrate. Now what happens? Now see, this will be the current position of all the molecules. They will be fixed at the position, but they have got slight space so that they can vibrate at their position. Now suppose if I start heating from one end of the solid object, if I start providing heat energy from one end of the solid object, then what will happen? This end will acquire heat energy from this heat source. This end will acquire heat energy from the source and its vibration will increase. That is, its rate of vibrating that will be increased. So further what will happen? It's going to acquire the heat energy. It's going to vibrate more randomly. So now what will happen? As it vibrates, it's going to transmit its vibrational energy or let's say the heat energy that it has acquired to the neighboring molecules. So what will happen? The vibrational effect, the energy will be transmitted to the next neighboring molecule. Then further, as the heat energy is going on adding up in this molecule, its vibrational effect is going on increasing and the next neighboring molecule is going, now again it will start vibrating and its vibrational effect will be produced, enhanced. Now further, this effect goes on transmitting from one end to the other and finally the heat is transmitted at the other end. So what is happening? The gradual transmission of heat from one end to the other, this method is known as the transfer of heat by the method of conduction. In conduction what we can see that molecules are vibrating. When molecules vibrate, they are transmitting the heat energy acquired from the source to the next neighboring molecules. This is what is happening. So let me show you gradually what things will happen. If I redraw this same picture again, this is the solid object. Now the first you will find that the heat energy of the molecules which are very near to the source, its vibrational effect is going to increase, or let's say it's the heat energy that it will be having that will be more. So I'm drawing with this magenta color, or you can take this as light red color. That means it has got more energy. It has got more energy. Now the next one that will be having less heat energy, let me draw that with this light yellow color. So this shows that it's going to have less heat energy. And finally, the molecules which are at this end, they will be having the least heat energy with them. So let me show this with this white color so that it depicts that this is going to have less amount of heat energy. Easy, I believe that the concept of conduction would be clear to you all. See, this is actually depicting high heat energy content within the first end of the molecules. These molecules are going to have high heat energy, and this is going to have the least heat energy. And all this is taking place due to gradual transmission of heat from one end to the other. Least amount of heat energy is having the highest amount of heat energy. Now again, try to understand how conduction is taking place. Conduction, first of all, it is not an instant process. It will gradually flow, the heat will gradually flow from one end to the other end. This is what will happen. And this flow is taking place due to vibration of the molecules. Molecules are vibrating, and this vibrational effect is transmitted to the next neighboring molecule, and then to the next, from this next neighboring molecules to the again the molecules which are ahead of that. It is gradually transmitted from one end to other. Now what will happen in the process? If you are going to on heating it, you'll find that this heat energy will be transmitted to the entire rod, or let's say to the entire end of the object. So entire object gets heated up. Now see, in your kitchen you would have, if you have experience cooking, you would be finding that if you hold a metallic object, anything from which you can actually take out your food, if you find that, if you put on flame, you'll find that if the entire metallic object is made up of metal, there is no wood contact, you'll find that you're heating at one end, your hand also gets heated up. Why is that so? Because heat is getting transmitted from one end to the other end, and thereby your hand also gets heated up, or let's say you feel the heat energy which is within the object. That is how the heat transmission that has taken place by the process of conduction, and that takes place by this method. So what you do, take note of all this, and let me start from the other end. So I believe that you would have understood the concept of conduction, how heat conductivity takes place in solid. Now there are many practical applications of the concept of conduction. Let me go ahead and let me talk about the practical applications of this conductivity concept that we observe in our day-to-day life. Now, as I told you about the kitchen utensil just now, I told you about, let me talk about conductivity and how can you use this concept in your day-to-day life. Now, first of all, you would have observed that the utensils of kitchen are made up of wood. Why is that so? Because wood is a bad conductor of heat. So when heat is transmitted from the pan of the utensil to the handle of the utensil, the handle is also made up of metal, but actually we cover it with wood, so that heat conductivity will not take place through wood, and you can easily actually handle the utensil. So utensils are handle of the utensils are made up of wood. Handle of kitchen utensils are made up of wood. This is one of the practical applications. Handles of kitchen utensils are made up of wood. Now next thing, more applications. Now if you see that, you'll find that a new quilt actually warms more compared to an older one. Why is that so? Let me write it, and then I will tell you. A new quilt feels more warmer compared to an older one. Feels more warm compared to an older one. Now, why is that so? Why a new quilt? Just because of its quality or something else? Compare to older one. Now see, in the new quilt, there will be pores where air will be trapped. Now air is a bad conductor of heat. So whatever heat our body has that is not transmitted to the external environment, so that's why we feel more warm in a new quilt, because it has got more tiny pores. Because of more pores in which air is trapped. More pores in which air is trapped, and air is a bad conductor of heat. This is the reason in which air is trapped. Now, two applications you can think of for more. There are more applications. Now, see, Eskimos when they build their house, they build their houses of bricks made up of ice. That is, for using ice blocks, they actually build their house. Now, they actually make double wall. Eskimos actually make double wall. Why is that so? Eskimos build double walled house. Why is that so? That's quite simple. Eskimos build double walled house because doing this or doing such thing, this will entail trapping of air in between the walls of the house. When air is trapped in the walls of the house, no heat can be transmitted from inside to outside, and hence you can feel warmer inside, as air is trapped within the walls of the blocks for which they are using to make up their house, that's igloos. Now next one, we can think of more applications. Now see, if we use two quilts, that will appear to be more warmer compared to using one thick quilt. If the thickness of the one quilt that you have taken, that is equal to the thickness of two quilts that you have taken, but still two quilts if you use together, that will appear to be more warmer. Why is that so? Because again, air is trapped between the spaces of the quilts, between the quilt clothes. Then that's why again air is a poor conductor of heat. It will not allow heat energy from your body to flow out. So two quilts provide more warmth compared to one single quilt of same thickness. Provide more warmth compared to one quilt of same thickness. One quilt of same thickness. Next, after this, you can think of more examples based upon all this. Now see, you will find that even in our homes, we have actually pipes through which hot water is flowing in winters. We have actually pipes so that rooms can be heated again. This heat is transmitted through the pipes by conduction method, and then again by several methods the air gets heated up. Now next thing, even if you find that wooden houses are made in places where there is chilly winters. Why wooden houses are made? Because heat energy from the house cannot escape into the external environment, because since wood is a bad conductor of heat. So all these are practical applications of the concept of conductivity. Let's go ahead with some more demonstration. Now I told you how heat flows. Let's do an experiment. If I take a metallic rod, this is a metallic rod, let's say. Now what I am doing, I am heating this one end of the rod using a burner. I'm using a burner, and let's say I am heating this one end of this rod using this burner. Now what will happen? Gradually the heat energy is going to transmit from one end to the other. Let us attach some thermometers at the various ends of the rod. So if I attach various thermometers at various ends, let's say this is thermometer 1, let's say this is thermometer 2, let's say this is thermometer 3, and let's say this is thermometer 4. So we have attached 4 thermometers here as shown: thermometer 1, thermometer 2, thermometer 3, thermometer 4. Now before starting heating from one of its ends, we will find that the entire temperature of the rod is uniform, and that will be at the normal room temperature, let's say, before starting heating. So that means all the thermometer is going to record the same temperature. Now as we start heating, what will happen? Heat energy will start transmitting from one end to the other end. You see, understand? As we start heating. So what you're going to obtain? You're going to obtain that heat energy is going to transmit will depict that temperature will start increasing. So what will happen? Temperature starts increasing, and let me mark this end A and this end as B. So temperature will start increasing from end A to end B. Temperature increases as you move from left end to right end. When temperature increases, that means this thermometer will start showing rise in temperature. But still, this part, till the time heat flows, this part will be having lower temperature. This is what we're going to observe. Now, this thermometer will show a temperature will be lesser than T1. This one will be again lesser than T2 also, and this one will be the most least temperature recorded by this thermometer, that is T4. This is what we are going to observe in this case. Next, let's proceed. What I want to tell you, you will find that for some time the temperature varies. Means T1 temperature will gradually go on increasing. T2 will also go on increasing. T3 also will go on increasing, and T4 will also go on increasing. So first of all, let me tell you some states. We are going to have variable state. Variable state means till the time temperature varies of each of the end. Because what is happening? Heat energy is transmitting from end A to end B. So what is happening? Temperature is changing. If I take any point, 2 points M and N, if I take 2 points M and N, we'll find that the temperature of M and N are not constant, it's varying, so they are in variable states. So this is for the time being, the temperature varies of any point. For the time being, temperature keeps varying for any point on the rod. So that means that point is in variable state for any point on the rod. Now next thing, what will happen if we go on continuously heating the end A? If we go on heating continuously the end A, then what is going to happen? Then we are going to see that temperature will go on increasing. Temperature goes on increasing, and as temperature goes on increasing, but after some time what will happen, we'll find that temperature of T1 will be fixed, temperature of T2 will be fixed, temperature of T3 will be fixed, temperature of T4 will be fixed. But T1 will be lying at the highest temperature, T2 less than that, T3 even less than that, and T4 the least one. In this case, although the heat transmission is taking place, but the temperature difference or the temperature of any end remains constant. So that means a steady state is reached. So second one, we have a steady state. By steady state, what do I mean? I mean that a steady state is obtained by each of its end. So every end or every point acquires a constant temperature. Every point acquires its own constant temperature. So that means steady state is reached, acquires its own constant. Why I am saying acquires its own? Because every end will be having a different temperature. Acquires its own constant temperature. So if end A is, let's say, 100 degrees Celsius and end B is maintained at 20 degrees Celsius, so they will be maintained, and each one will be having a temperature between 100 and 20. Let's say this is 80, this is 60, this is 40, this is 30, and so on. This is how the steady state will be obtained by each of the end. So this is how what was happening. The third thing, if I talk about that, is temperature gradient. Now temperature gradient. Now with each unit length that we have covered, temperature gradient. Understand what is temperature gradient? Now see, we are finding that temperature is decreasing from end A to end B. If I take any small length on this, let's say rod, if I take any small length, and let's say this length is given as dx, the change in temperature from this point to this point, understand, the change in temperature from this point to this point, let's say that is dt. So change in temperature per unit length, that will be dt by dx, that is the temperature gradient. So let me say from right hand to left hand for a very small, for a infinitesimally small element, we have change in temperature as dt. So temperature gradient will be given as, if I write that as, that will be equal to minus dt by dx. Why minus? Because dt is change in temperature. Change will be negative here, because see here, this end is having a lower temperature, a lower value minus a higher value. That means we are going to get a negative value. To keep the temperature gradient positive, I am multiplying a minus sign here. That will give me minus dt by dx, that will give me a positive value. Hence, temperature gradient is minus dt by dx. So what we have, I have written change in temperature. So let me also show you here that I am also marking change in temperature, that is dt for this end. This is what I was intending to show you all with all these things. So this was all the basic concept of thermal conductivity, and let's go ahead to calculate with what rate heat energy flows through a conducting rod or any solid object which is good conductor of heat. Let's go ahead and let's talk about thermal conductivity, or how heat energy, how it is rated with the dimensions of the object taken and with some other property of the object. Let's talk about thermal conductivity. Now any object, let me draw an object and show you. Any object, if you heat from one of its end, you'll find that heat energy is going to be transmitted to the other end. This is what we find. Here I am drawing a solid object as shown. Hope that the three-dimensional view of this object would be clear to you all. See, I have taken a solid object which is cubical in form, it's a cuboid structure it has. Let's say the ends are marked as, this is end A and this face is end B. Let's say the area of cross section of its face, this is given as, this is kept constant, this is given as A. A is the area of cross section that we have here. Area of cross section, that is equal to A. Now let's say the length of this object that we have taken, this length is L. These are the dimensions that are provided to us. Now see, observe this cube. If by any means, if by any source I heat up this end A. Oh, I have taken here also area of cross section A, here end A. So let me mark these ends are M and N. So that will be more better way to depict the ends, M and N. Now see here, I am providing heat energy to one of its end. I am providing heat energy by any source. We are providing heat energy, and heat energy will be gradually transmitted through the entire solid from one end to the other end. So let me show you that heat energy transmission is taking place within the entire solid object. Heat energy transmission is taking place. Now let's go ahead. If I talk about rate of heat energy transmission, that is, if I depict heat energy with Q, how heat energy is transmitted per unit time. So let me mark here rate of transfer of heat. Rate of transfer of heat. Let me show you here rate of transfer of heat. This will depend upon three factors. This will depend on three factors. First of all, area of cross section, the length of the cube that has been taken, and one more property. Let's talk about, first of all, rate of transfer of heat. Let me write this as delta Q by delta T. This will be proportional to area of the cuboid that we have taken. So let me write this is proportional to area of the cuboid or area of cross section, that is A, we have taken. So what we can write, this first relation that we've obtained, we can write this delta Q by delta T is proportional to area. Now, I was heating from one of its end. Let's say the temp and steady state is obtained. Let's say its temperature is T1, and let's say here the colder end, whose temperature will be lower than temperature of this end, that is T2. So let me mark here the temperatures maintained are T1 and T2. That is, we have maintained the temperature of these two ends, and remember, steady state is obtained. But still, heat energy will be transmitted. Let's say T1 is 100 degrees Celsius, T2 is 20 degrees Celsius. Heat energy will be transmitted.